This is Dan McInerney from Protect AI. Today we're going to be looking at the tool Kubeflow and talking about how the vulnerabilities in it were discovered and tips for doing this yourself. Whenever we first start looking for bugs in a target, the step one is always to click every link and submit every form you can in the application after you've already started Burp Suite to intercept those requests. Here we see Burp Suite. It is populated with all of the different links and forms that I've submitted inside of Kubeflow. Now, the first thing that stood out to me in Kubeflow is the fact that after authenticating, a user can run Jupyter notebooks. This essentially means once you're authenticated, you have a direct route to code execution within the Kubernetes cluster, which makes this application a very valuable target to hackers. So we're going to want to pay special attention to anything that allows us to access this application without access to a user's password. In this case, we have a Jupyter notebook here where we are printing os.environ, which shows all of the environment variables of the server that's hosting Kubeflow. I've already populated Burp Suite with all the forms and requests I could find within Kubeflow. In normal web application testing, this is the point where we go into Burp Suite and we sort the requests by unique put and post and send those to the automated scanner. The reason we do that is because put and post make server-side changes. That's usually where vulnerabilities are going to live, rather than GET requests, which just request information off of the server. Now there's a caveat though with machine learning tools. What I've noticed is that the output of machine learning engineering pipelines isn't just code or applications like it is for normal development, it's actually data and models. So what I've seen is that in machine learning tools like Kubeflow, they tend to give the user too much flexibility in where these data and models live, as well as too much flexibility in the importation and exportation of them. We saw this in MLflow when we were able to download any file off the MLflow server through the MLflow interface. So after I've added the put and post requests to the automated scanner, I'm actually going to go find the request in Kubeflow that lets me download artifacts. So we sort here by method. We find unique puts, send those to the active scanner. Now, while I was testing Kubeflow, I did notice that there was a request that looked eerily similar to the MLflow request that we found was vulnerable. And it looks like this: get artifact. Here's the first instance of it. We can see it's get pipeline artifacts, get. We have the source is the folder that it's supposed to be in, or the actual protocol. The namespace is the authentication authorization. Bucket is the folder it's supposed to live in, and the key is actually the file path itself. Now, whenever I'm in machine learning tools and I see a file path in any of these requests, I'm immediately going to do a deep dive into this request to see what we can do with it. What we're going to do with this request is send it over to Repeater and also do an automated scan. So we're going to kick off the automated scan by hitting do active scan right there, and also send it over to Repeater. And we'll make sure it's actually working. Yes, it's working. And next, we are going to check how the automated scan did. And what we notice in the automated scan is that a whole bunch of these parameters inside of this request lead to external service interaction. It says it is possible to induce the application to perform server-side HTTP requests to arbitrary domains. What that means is that you can payload a URL, and then when you send that request to the Kubeflow server then sends a new request out to an arbitrary server of your choosing, a hacker's server, a database, whatever it wants. Then the response from that arbitrary server comes back to the Kubeflow server, and the Kubeflow server sends that back to the user that made the original response. Now, this is dangerous for a number of reasons, but we'll see why this is particularly dangerous in this instance. And that is because it sends some sensitive information. So what we're going to do is copy the link to the public collaborator server, which again is just a public server that Burp Suite stands up for you for this type of testing. We'll go back to Repeater and we'll payload the namespace with this arbitrary public server. In this case, it's ostify.com. We send it and we get a curious response. Now, I know that this is coming from the collaborator server because I've used this before, and the collaborator server always returns this HTML body with a identifier string. So let's go back over to collaborator and let's see what actually happened on the collaborator side. The request it received is full of details, the most interesting of which is the authentication cookie. Kubeflow actually sends the user's authentication cookie when it makes this external request. So if you control this public server, you can get the authentication cookie of a logged in user. There's a little bit more information here, like this X-Envoy peer metadata. This is some pretty good stuff for an attacker. It's base 64 encoded, so we'll just decode it right here. And we see it tells us internal IP addresses, version numbers, names, templates, all kinds of interesting data for a hacker. But still, by far, the most interesting is the fact that it sends the authentication cookie with the request. What this means is that as an attacker, you can take this URL path here, payload the namespace with a server of your choosing, one that you control, and then send this link to a user of the Kubeflow application that you know is logged in. Now, when that user looks at the URL, they're going to see what appears to be a link to their actual Kubeflow installation. So they're going to have a level of trust in that link that clicking it is not going to cause any problems. So let's say they're hosting it at kubeflow.com. It'll say kubeflow.com/pipeline/artifacts/get. They see that link, they click it, they don't really get an interesting response. It just seems to error out, or they get this weird string, and they're like, oh, that's weird. I guess the link is broken. But you, as the attacker, now have access to their authentication cookie. You take that authentication cookie, you import it into Firefox, you hit the Kubeflow server, and now you're logged in as the user that clicked that link. Now you have access to code execution, you have access to all of the information, models, data that the machine learning engineer was using. You have a few other attack options. You control the HTML that's returned from this response. Meaning if you don't want to log into the Kubeflow server using their authentication cookie, you can also just hijack that user's browser by putting malicious JavaScript into the HTML of the URL that you payloaded. So in this instance, instead of returning HTML body 5u whatever, you'll actually return a JavaScript script, something like a beef hook that then hijacks their browser and lets you redirect them wherever you want, or pop up a password that asks for their Gmail password, things of that nature. Lastly, you can also use Kubeflow like an internal proxy. So you have to make a little bit of an edit here. When we make this request and we payload the namespace, if we go back over to Collaborator and we look at the actual request that was made, you'll see the request was made to a subdomain, ml-pipeline-ui-artifact. Now, this is the only request that sends the authentication cookie. However, you can also simplify this and payload the bucket parameter. If you payload the bucket parameter, then the authentication cookie doesn't get sent, but you can get just the base URL that you're looking for. So when you send this, you're actually not going to go to ml-pipeline-ui-artifact. You're just going to go straight up to the domain. So by doing this, you can actually see what other servers are on the internal network and return their data. In this case, we know there's 223:80 in our Kubernetes cluster. So if we send a request, we get RBAC access denied. That tells us that this exists. This internal server exists. What if we did the port 801? Then nothing happens, nothing returns. But you can use this to actually request any website on the open internet. We can use it to request Protect AI. And here it turns Protect AI. So you can use Kubeflow to launch denial of service attacks. You can use Kubeflow as an internal proxy to access resources on the internal network if you're on the external network. This is assuming that you already have authentication into Kubeflow itself. We wrote a tool called Kubejack in order to highlight this vulnerability. Now let's go through how to use it. In order to first get the payloaded URL to send to a user of Kubeflow and get their authentication cookie, we're just going to use the fetch cookie attack here. So we're doing python kubejack.py. The fetch cookie argument tells us which attack we're using. The attacker URL is the URL that you control. In this case, it's a burp collaborator instance. And the Kubeflow URL is the URL of the Kubeflow instance. We hit enter, and we get the payloaded URL. This is what you want to send to the user. Just copy and paste that and send it off. Now, what if you want to use that cookie? Well, we can go ahead and do send get attack. We're going to use the cookie we just got from the previous payload, and we're going to send a get request to any arbitrary URL. It can be an internal network URL, it can be an external network URL, whatever you want. In this case, we're doing the -- send get, which tells us we're going to do the proxy to get request attack. The get URL is the URL you want Kubeflow to go fetch. The path is the path on that URL that you want to fetch. -- Kubeflow URL is the URL of the Kubeflow instance that we're attacking. And the cookie is the user's authentication cookie. That's auth service _ session. That's the cookie we're going to put in there. And so if we do that, then it returns protect AI HTML. Ways you can use this: if there's a router on the internal network, then you can request the internal network's router and get maybe a configuration file from it or something of that nature. If there's a file server on the internal network that's not password protected, then you can go get all the files on that file server. And that's how you use our KubeJack attack tool.
Ready to spotlight your skills? Join the hunt on hunter.com.